I am Professor Madan, Department of Mechanical Engineering from PSN College of Engineering and Technology. So now we are briefly explain the fundamental of kinematics with a suitable example and real-time applications for kinematics. Basically, the theory of machines have two different of machineries mechanics. One is a kinematics, another one is a kinetic. So this video we are focused on kinematics fundamentals. First of all, what is mean kinematics? The kinematics is nothing but the study of motion of the bodies or system bodies without consider the force. It is kinematics. And kinetics have same the study of motion of the bodies and system of bodies with consider the force. So the two different main different of kinematics and kinetics. So now we are briefly explain kinematics fundamental. So many contents for kinematics. First, degree of freedom. Second, type of motions, and third, link, joint, kinetic chain, etc. And fourth one is how to determine the degree of freedom for any one bodies, for structures and rigid bodies, etc. And the fifth one is a mechanism and structures. And the last one is a number synthesis. So here, first we are briefly explain the degree of freedom. Okay, so first one is, what is the degree of freedom? So degree of freedom is not the depending way of the motions. So only for the number of independence variable for the rigid bodies. So here the number of independence motion a system can have for rigid bodies in 3D space, like maximum degree of freedom is 6, like 3 translations and 3 rotations. So here the 3 translation means x, y, z, the 2 direction, x direction and y direction and z direction for 3 space rigid bodies. And here the rigid body in the plane motion has 3 degree of freedom. One is x, y, z. Any rigid body in 3 space has 6 degree of freedom to, like robotics arm. So the robotics arm have 6 degree of freedom, including industrial robotics and artificial means industrial robotics and home robotics. So the robotics have maximum 6 degree of freedom. So 3 rotation, 3 translations. It is a degree of freedom. The next one is type of motions. So mostly 3 type of motions for kinematics machineries. First one is translation motion, second is a rotation, and the third one is a complex motion or the combination of translations and rotation motions. So here, first the translation motions, they have to move on object in x, y and z. But the rotation motions have to rotate off 360 degrees or the curved linear motion of the rotation motions. So here the rigid body free to move within a reference frame will in general case have complex motion, which is simultaneously combination of rotation and translation. So next, so 3-dimensional space have 3 translation and 3 rotations, and 2-dimensional space and or in plane we have combination of rotation the one axis and translation is a revolve into the another axis along with the 2 axes in the space. We will limit our present discussion to case of planar the 2-dimensional kinematic system. Here already I told is a rotation, translation and complex motion for the type of motion of kinematics. And rotation means the body one point which has no motion with respect to the stationary frame for reference. So all the point on the body script are about that center, a reference line down on the body through the center change only its angular rotations. So the pure rotation is depend upon the angular orientations, but the pure translation is not changing angular orientation. You have to refer line draw on the body change in linear position only. So rotation will have angular orientation, and the translation means is not angular orientation but is a linear motions. And next is a complex motion. Complex motions is a combination of rotation and translation. That's all. So here with the one application is there. The pure rotation means the vehicle wheel in case of car or bike. So many translations for wheel is a good example for the pure rotation motions, and pure translation means it chases. So it's the example for moving on x, y, etc. So and complex motion is a combination of rotation and translation. In your own system, it have same the object is rotated. The revolution or the moving on translation. So this example we discuss in coming slides. Next, third one is a link, join, and a kinematic chain. So nothing but link is rigid bodies. Simply I say. Link is a rigid body which possesses at least two nodes which are point from attainment to other link. So here, I have projected the binary link, ternary link, and quaternary link. So binary link you have one rigid body but two nodes, and the ternary link is one rigid body but you have three node, and the quaternary link is a one rigid body but it have four nodes there. So this node is depending on the link and the rigid body processes. Okay. So many link is there. So I have this small explanation of small and applications: binary link, ternary link, and quaternary. Here already told some common type of link is a binary link, one with two nodes, ternary link, one with three nodes, and quaternary link, one with four nodes, and pentagonal is a 5 nodes, hexagonal is a 6 nodes. But binary, ternary, quaternary, and quaternary, hexagonal is a one rigid bodies. So next, join. The join is nothing but this joining connect link show relative motions. The join to connect the link with the relative motions is a good example, good definition of join. The join is a connection between two or more links which allow same motion or potential motion between the connector link. The join is also called as kinematic pairs. Can be classified in the several ways. First way, by the type of contact between the elements, line, point, and surface. So many contact is there for elements. So particularly, they are very important for line contact, point contact, and surface contact. These three contact we will briefly explain by upcoming slides. And the second one is by the number of degree of freedom allow at the joint. Okay, it's a very important. We consider for the degree of freedom. And the third one is this type of physical close of the joint, either force and form closed. And the last one is by the number of link joint. in order of the joint, line, etc. And another is very important, the classification of contact. So the already I told three is important contact. One is a line contact, one is point contact, and another is a surface contact. Here there are two types of low pair. There are two types of contact for classification. One is a lower pair and a higher pair. The lower pair is have surface contact, and higher pair have point or line contact. It is the high pair and is a low pair. The main practical advantage of lower pair over higher pair is their better ability to trap lubricant between their developing surface. So for example, good example, the assembly line mechanism chains of link. The joint is a conveyor, so picking pace robot. So it's one type of applications, and another is a very important applications in the bicycle transmission device for chain. The chain is a good example for joining of kinematic pair. Here so many link is there, but so many is a the bicycle transmission is binary link we are using in your two mode, and this binary link to connecting seriously by the joint, it have two same motions. So it's a good example for bicycle transmissions device. Here lower pair, already I told lower pair means is meaning of have point or line. So some example for the lower pair. Revolved and prismatic, screw, helical, cylindric, spherical, and flat. So first revolved. Revolved means joint. They have 1 degree of freedom. So already I told degree of freedom means the independent variable. Here this figures they have two rotation motion only for only one rotation is there. So you have to 1 degree of freedom. And prismatic joint, it has not a rotation, but it is a moving on translation. So it's a translation for x direction. So the square x section is moving on only for x axis. So only 1 degree of freedom for prismatic joint. Second, third one is application of helical joint. They have 1 degree of freedom because the screw is moving on, is rotating on only one directions. So it's not this a linear, it is not this a rotations. So only one rotators have 1 degree of freedom for helical. So another one is a cylindric joint because the 2 degree of freedom means it is have one linear motions, and at the same time the shaft is rotating one revolution. So this system, the cylindrical have 1 translation, 1 rotations. So have 2 degree of freedom. And the next is a spherical joint. So spherical joint has 3 degree of freedom. So look that delta alpha, delta beta, and delta gamma means is rotating 3 directions: x direction, y direction, and z directions. It will be rotate. So you have to 3 degree of freedom for spherical joint. It is a contact. It is not surface contact. It is have point contact. And helical and cylindrical mean is contact of line contact. This chapter we discuss in lower pair. So this all the diagram have linear, line contact and point contact only. It is called lower pair. Okay. Last is a planar. The planar is a 2 linear motions, and x direction and y directions, 2 degree plus 1 rotation is there. So finally total 3 degree of freedom for planar, x, y, and 1 rotations. Okay. Another is classification by the number of degree of freedom allowed at the joint. We can classify joint by the number of degree of freedom allowed at point joint as 1 degree of joint, and another name is joint, full joint, and half joint, and 3 degree of freedom joint. For example, 1 degree freedom joint or rotating pin joint and translating slider joint is an example for 1 freedom joint. And another is example 2 freedom joint is link against plane and pin in slot is a 2 freedom joint. And finally 3 freedom joint, it has spherical ball and spherical ball of the jacket part. So it is a full joint, half joint, and 3 freedom joint. Then the example for full, half, and 3. First diagram is a rotating full pin joint. So it have 2 link we have used. So 2 link, and how many joint is means 1 joint. 1 joint is there, but motion of the link you have to curvilinear. So 1 degree of freedom. So it have 2 link, 1 joint, and 1 curvature motion. So 1 degree of freedom. Next, translation full slider means it is a slaughter machine slider. The slider is moving on only for x directions, only 1 direction. So here is a 1 degree of freedom. And half freedom joint, it have link again plane. So this is a 2 link is there, but same time it is a rotations for 1 rotation and 1 linear motions. It is not for you see for joint. It is only for rigid body. So 2 motions is there. One is a linear, one is a curvilinear. So it is a 2 degree of freedom. And a pin in slot, the pins are 2 rigid bodies there. One is a fixed, one is a moving. This moving link is connected to the point joint, and the link is moving on x directions as well as is a curvilinear motions. So the pin in slot is have 2 degree of freedom. And finally 3 first order pin joint is a 1 degree of freedom because 2 link L1 and L2 is a 2 link and 1 joint, but the link 1 2 link only to move in curvilinear motion. So it have to 1 degree of freedom. But the second diagram, 3 link is there, L1, L2, L3, 3 link, and only 1 joint is there. But link L2 and L3 is have moving in curvilinear motions. But L1 is not moving, is a fixed. So total 2 motions there. So finally the 2 degree of freedom for pin joint. And the next one is kinematics chain. So already we discussed in link and joint is continued to for the kinematic chain. The kinematic chain kinematic chain means a kinematic chain is a series of linked joint to connect to the series for linked joint. So as well as the assembly of link and joint interconnected in a way to provide a controlled output motions in response to a supplied input motion. So the kinematic chains have 2 main things about. One is a mechanism, another one is a machine. Mechanism and machine is nothing but the mechanism is kinematic chain in which at least 1 link has been grounded or attached to the frame of the reference. So the mechanics means is a rigid structural. So for example, we have to use for 4 link is L1, L2, L3 and L4. But any one link for L1 link is a reference is a fixed one. Remain L2, L3, L4 is any one motion is there. So it is called as mechanism. The 4 link link, only one link is arranged for the 4 link. It is called as a mechanism. And the machinery is nothing but combination of resistant bodies arranged to compel to the mechanical force. The mechanical force we converted to the useful work. It is called as machine. So many examples for machine is there. So for engine, for any one energy is converted to the useful work by using linkage. It is called as machines. And ground. Already told us ground is a fixed one. Ground, any link or any link is fixed with respect to their reference frame. We have used for the 3 link, so one link, that time one link will be fixed one. And crank. Crank means the complete revolutions. Any one link have make a complete revolutions. It is a pivoted to ground. So ground with link is fixed. So the link, any one link, it's not for fixed. Any one link is moving in completely revolutions. It is called as for like here the reddish mean is a ground, is a fixed. The ground red means the mention means it is a fixed link, so there is no movement of the red link. Remain 2 link is there. We are assuming for L1, L2 and L3. There's a 2 link is rotate in the one any one L2 link or L3 link is rotate in 1 revolutions is called as crank. Rocker means the link has an auxiliary back and forth rotation and pivotal. Here the means the blue means is grounded fixed, and another link L2 and L3. For L3 is a rotating crank, 1 revolutions, but the L2 is accelerated, is not for rotate, is accelerate, is a axis of grounded. It is called as a rocker. So here 1 crank and 1 acceleration is called as rocker. And coupler, the link which a complete complex motions, and it is a pivotal here to ground. The coupler means complex, there is no more movement or no more acceleration, there are no more linear motions. It's a very complicated for as a coupler. Next one is how to find degree of freedom for any rigid body or machines or mechanisms, something, etc. The degree of freedom is on the mobility of the system. The number of independent input which need to the provider in order to create a predictable output, or the number of independent coordinate required to define a position. The degree of freedom is a planar mechanism to determine the overall degree of freedom (DOF) of any mechanism. We just account for the number of link and joint and for the interact among them. The main mobility M of the system, that is degree of freedom, is calculated by using the Kramer conditions. The Kramer conditions are very important to find degree of freedom. Any link in the plane has 3 degrees of freedom. Therefore, a system of L unconnected link in the same plane will have 3L length 3L degree of freedom. When the link are connected by the full joint, this removed 2 degrees of freedom, and then this link are connected to the half link joint to move only the 1 degree of freedom of the system. In addition, when any link is grounded attached with the reference line on all 3, it is a degree of freedom is zero. So here how to find degree of freedom. So number A, 2 unconnected link. So there are 2 links like name is L1 and L2. So L1 link is a one link and two nodes, and L2 is a one link, it is have two nodes. The L1 is rotating only one curvilinear motions, delta theta 1. At the same time, the linear motion for delta x1 and delta y1. So here two linear motions and one rotation motion. So 3-degree is there. Another L2 link, it have delta x2 and delta y2 for two linear and one revolution. Delta is delta theta 2. So the system have 4 translation and 2 rotations. So finally it's a 6-degree of freedom of unconnected link. And this is a connected link by full joint. Here 2 link is there, but this link is connected by using joint. So L1 and L2. So here the 2 translations cut. It's a x1, x1, x2 and y1, y2 is a combinations because it's a connected. So here 2 translation motions and 2 rotation motions. So degree of freedom is 4. And C1 is connected by the roll slide joint. Here 2 link L1 and L2, separate them. And the link 1 is moving x direction and y direction, and at the same time is a curvilinear motion. And L2 is moving on only one direction, translation, linear, is a delta x2, and is curvilinear for link 2, delta theta 2. So here 3 translation linear motion and 2 rotation motions. So here 5-degree of freedom. And we are using for the Kepler equations, like find out how much degree of freedom is there for any one rigid body or structure or machines, etc. Here the main formula for M is equal to 3L minus 2J minus 3G. So mentioned is that L means number of link, J means number of joint, and G means number of grounded link. It is called as a Kepler equation. Okay, listen. Note that any real mechanism, even if more than one link of the kinematic chain is grounded, the net effect will be create one larger. Higher order ground link or there can be only one ground plane. Thus G is always 1, and the Kepler equations become M is equal to 3 L1 L1 L minus 1 and minus 2G. Okay. So here is only example for the how to find the degree of freedom. Here how many link is there for this diagram is 8 link is there. L1 is grounded link. So how many grounded link means 1, 2, 3, 4 grounded link. So we consider for the one link 1, and the link 2 means is a crank. It's a rotate for the 3 degree rotations. So the link 2 is a crank, and the link 3 is a accelerate. So it is not rotate, it's not, this only for accelerate. And the link 4 is the same as accelerate, and the link 5 means is a ternary link, and 6 and 7 8 is this link is a binary link. So totally 8 link is there. And how many joint is 1, 2, 3, 4, 5, 6, 7, 8. 8 link, 8 joint is there. 8 joint is there, 8 link is there. Here, how many 6 link is there? So 2 ternary link, link 2 and 3 is a ternary link, and 4, 5, 6 is a binary link, and the grounded link is a fixed. So there are 3 grounded link is there. Link, but we consider for one link. for grounded. So how many 6 link is there? And so join is 1, 2, 3, 4, 5, 6 join is there. The degree of freedom of the assembly of link completely predicts its character. There are only 3 possibilities. If the degree of freedom is positive, it will be a mechanism and the link will have relative motions. If the degree of freedom is exactly 0, then it will be structure. Yes. In case the degree of freedom is 0 means there is a structure, there is no movement of the link. Yes. He said there is no movement, it's a equilibrium. Yes. And is no motion is possible. If the degree of freedom is a negative, then it's a preloaded structure. 0 degree of freedom is 0 means structure, and negative value is preloaded structure, which means there is no motion is possible, and the same stresses may also be present at the time of the assembly. Here, first diagram is a 1, 2, 3, 4. 4 link is there. 4 link is there. So how many join is 1, 2, 3, 4? 4 join, and 4 link is there. The link is a binary link. Here link 1 is a grounded, so we consider for link 1. And another is link 2 is a crank link, because it's a rotating element. And link 3 is a accelerate translation, and link 4 means accelerate. So here the degree of freedom means only for one direction, so only one acceleration, curvilinear motions. So it is a degree of freedom is 1. Here, second diagram, the structure is degree of freedom 0, because the 3 link is that there is no motion, because the link 1 grounded and link 2 and link 3 is not moving, because it's arrest. So degree of freedom is 0. And a preloaded structure means there are used 2 link. This link is minus degree of freedom. Okay. The final one is number synthesis. Number. So determine the number and the type of link joint needed to achieve a specific degree of freedom and motions. So as an example, so many seconds there, and the number is a determination of the number and order of link joint necessary to product motions of the particular degree of freedom. Order in this context refer to the number of the nodes per link, the binary, ternary and quaternary, etc. Hypothesis. Okay, it's very important for hypothesis. If all the links are full joint, so full joint and odd number of degree of freedom requires an even number of links are vice versa, it is called as a hypothesis. And proof means all even integral can be denoted by 2 meter or by 2n, and all odd integral can be denoted by 2 meter 1, 2n minus 1, where n is and m are the positive integral. The number of the joint must be positive integral. Let we explain for Kepler equations. Here means J is equal to 3 by 2 L1 minus 1 minus m divided by 2. Here L means the number of link, J means the number of joint, m means degree of freedom. So substitute m is equal to 2 meter and 2L 2m, so both by any number. So we are present the replace of J is equal 3n minus m minus 3 by 2. This count result is J being is a positive integral as here. Try. See here is both an odd number j is equal to 3n minus m minus 7 by 2. This also cannot result in j being is a positive integer as here. And another is odd and even, both of odd and even. J is equal to 3n minus m minus 2. This is a positive integer for m is greater than equal to 1 and n is greater than equal to 2. And here even and odd, this for j is equal to 3n minus m minus, this is possible integer for m greater than 1 and n greater than 2, the same of odd and even. So in the 4 example of 1 degree of freedom mechanics, we can only consider combination of 2, 4, 6, 8 link. Later the order of the link can be presented. B means binary, T means ternary, Q means quaternaries, B means pentagonal, H means hexagonal. Okay. The total number of link mechanism will be L is equal to P, T, Q, B and H to be added. It's a total number of links. Since 2 link nodes are needed to make one join, so join means node by 2 and node is equal order of link in the number of link of that order. So finally the join is equal 2 binary, 3 ternary, 4 quaternary, 5 is a pentagonal, 6 is a hexagonal, etc. divided by 2. The substituting the values for above equations, you finally got m is equal p minus q minus 2p minus 3h minus 3. So from this analysis we can see that for 1 degree of freedom there is only one possible 4 link is configuration, the 2 6 link configuration and 5 possibilities for 8 link using binary or hexagonal link. Okay. So final the tabulation of degree of freedom planar mechanics with the revolve join and up to 8 links. So how is the start? The link is starting from 4 to 8. In case is a binary, ternary, quaternary, pentagonal, hexagonal. This link we substitute in here m is equal b q minus 2b minus 3h minus 3. We are applying this. So binary is a 4, ternary 0, quaternary 0, and also for link 4. In link 6, 4 2 0 0 0. So binary 4, ternary 2. So it's a continue. Link 8. So totally link 8, binary 7 and hexagonal 1. In case is possible. And in case 8 link 4 binary ternary 4 remain is 0 is possible in case. Another is possible 5 to 1, so binary 5 ternary 2 and quaternary 1. And 8th another one is 8th 6 binary join and 2 is a quaternary. And the final the link 8 is a 6 binary 1 ternary and 1 quaternary. Sorry, pentagon. So this is the degree of freedom for the revolved joint. Is a number synthesis. So now we have briefly explained the kinematics mechanism for simply I say. So thank you very much.